Section 6.2, our objective today is I can state the contrapositive and inverse of an if-then statement. So remember that if we are given an if-then statement, it's in the form of if P, then Q, where P is the hypothesis or the given information and Q is the conclusion, right? And we've already talked about what we call the converse of a conditional statement. And in the converse, remember that the hypothesis and the conclusion are switched. So if Q, then P. And remember we've talked about that if the original statement is true, so if this original statement is true, then there's no guarantee that the converse is going to be true, okay? And today we want to learn about two additional types of statements. And the first type is called the inverse of the conditional. So again, starting with our original statement, so if P, then Q. The inverse is created by negating the hypothesis and negating the conclusion. So if not P, then not Q. Okay, so that would be the inverse of the statement in yellow. If not P, then not Q. Okay? And again, if the original statement is true, there's no guarantee that the inverse is going to be true. And the second type, or actually it's the third type of statement, is what we call the contrapositive. And the contrapositive is created by first finding the inverse. So remember the inverse is if not P, then not Q. And then switching the hypothesis and the conclusion. So it would become if not Q, then not P. Okay. Now, the important point here is if the original statement is true, then the contrapositive must be true. If the original statement is false, then the contrapositive must be false. So we say that the conditional and the contrapositive are logically equivalent. In other words, they say the same thing. And so if the original conditional is true, the contrapositive must be true. If the original statement is false, the contrapositive must be false. Okay? So let's look at some examples here. Example. So here is my statement. If a quadrilateral is regular, then it is a square. Okay? The inverse of that statement would be if a quadrilateral is not regular, then it is not a square. Okay. Number 2. If a quadrilateral, if a triangle is equiangular, then it is not obtuse. Okay? And what we want to do is write the contrapositive of this statement. Okay? So in the contrapositive, we negate the conclusion and it becomes the hypothesis, and we negate the hypothesis and it becomes the conclusion. Okay? So the contrapositive is if a triangle is obtuse, because the opposite of not obtuse is that it is obtuse, then it is not equiangular. Okay? All right, so let's do a third example. If 2x plus 1 equals 7, then x equals 3. Okay? So first we want to write the contrapositive. Okay, the contrapositive, we negate this, and then switch them. Okay? So if x is not equal to 3, then 2x plus 1 is not equal to 7. Okay, so that would be the contrapositive. The converse, remember the converse comes by just switching the hypothesis and the conclusion. So if x equals 3, then 2x plus 1 equals 7. Okay? And then I would like to write the inverse. Okay? Well, the inverse comes from just taking the original statement and just negating and not switching anything. So if 2x plus 1 is not equal to 7, then x is not equal to 3. Okay? Would be the inverse. All right. Now, very often we want to know, is the statement true or false? Okay? Well, example 4. If a parallelogram is a square, then it is a rectangle. Okay? So which set, if I was talking about sets of things, which set would be greater? The set that of all rectangles or the set of all squares? Well, rectangles would be larger because a square is a special rectangle. So if we were going to do a Venn diagram, we would put a circle which represents our rectangles, and every square is also a rectangle, so inside the circle of rectangles is another circle that contains all squares. But remember, not all rectangles are squares, so there's other things. Okay, so is the original statement true? If a parallelogram is a square, in other words, if it is in here, then it is also a rectangle. Yes, okay, that is true. Okay, now let's write the inverse. Remember, the inverse is if not P, then not Q. Okay, so we would say if a parallelogram is not a square, then it is not a rectangle. Okay, so in this case, if we look at our Venn diagram, it's not a square. So where would it be? Well, if it's not a square, it could be here or it could be out here. Okay, so do we know for sure that it's not a rectangle? And no, we don't, so this is false. All right, so when something could be in two different places, then we have to say it's false. Now let's look at the contrapositive. Okay, and so in the contrapositive, it is, remember, if not Q, then not P. Okay, so the contrapositive is if a parallelogram is not a rectangle, then it is not a square. Okay, so in other words, if it's not inside this circle, then there's no way it can be a square, and that is true. Okay, and remember that our original conditional was true, and so our contrapositive must be true. Okay, so let's look at another example, number 5. If it is snowing, then the game is canceled. Okay, so our big set is game canceled. And one of the reasons we can cancel a game is that it's snowing. Okay, so the inverse, remember, if not P, then not Q. So if it is not snowing, then the game is not canceled. Okay, well, if it's not snowing, we could be here or we could be out here. So there's two places that we could be. So this is false. Anytime you could be two places, it's going to be false. Okay, now let's look at the contrapositive. Remember, the contrapositive is if not Q, then not P. So if the game is not canceled, then it is not snowing. Okay? Okay, so that is a true statement. Okay. All right, and let's look at one more. If WXYZ is a rhombus, then its diagonals are perpendicular. Okay, so so the given statement is true. Okay, and what additional conclusion can we come to, or can we come to a conclusion with each piece of additional information? So in other words, we know that the given statement is true. So if we also know that WY is perpendicular to XZ. Okay, so let's look at the picture. So WXYZ. And WY is perpendicular to XZ. Okay? Well, if that's all we know, then we can come to no conclusion. Okay? B. If we know that the diagonals are perpendicular and we know that WXYZ is a square, okay? If we know WXYZ is a square, then we know we can conclude that WY is perpendicular to XZ. Okay? And we can conclude that because a square is a rhombus, and so therefore its diagonals must be perpendicular. Okay? C. If we know that measure of angle XWY plus measure of angle WXZ equals 100. Okay? So this angle plus WXZ. Oops. Okay, so we know XWY, this angle, and plus WXZ, that angle. We know that equals 100. Then we can conclude that WXYZ is not a rhombus. Okay, and we know it's not a rhombus because if we look at this triangle, if these two, the two angles equal 100, then this cannot be a right angle. This right here cannot be a right angle. And so then we know that WXYZ is not a rhombus. Okay, and then the last one, we know WXYZ XYZ is not a rhombus. Okay? Then we don't know anything about the diagonal, so there's no conclusion.